possibilities that may be on the horizon. Medications like remdesivir that we discussed in our video update 11 that have shown promising results in a test tube and are in clinical trials with humans as we speak. Here's a paper that was published on February 24th that gives more information about how remdesivir actually works. We will put a link in the description below. This medication had gone through phase 1 trials already, had gone through phase 2 trials where they looked at safety again, except in a larger population. But when they did the phase 3 trials on Ebola, it did not work. So even though you can get something that works in vitro, it doesn't always mean it's going to work in vivo. You have to go through those phase 3 trials before the FDA will give it a label. Well, the unfortunate thing about this medication is it passed phase 1 and phase 2. So we know it's a medication that's relatively safe and it's sitting on the shelf looking for a job to do. And now enter this COVID-19 situation here at the beginning of 2020, and now it's being put to work directly into a phase 3 trial. So the nice thing here is that it didn't have to go through phase 1 and 2 because it already did that. So before we continue to talk about remdesivir, we need to follow up on what I illustrated in our last video, update 32, about how the SARS-CoV-2 virus that causes COVID-19 actually hijacks our cells, and how something called RNA-dependent RNA polymerase, or RDRP for short, is essential for the replication of RNA viruses. Please go back and watch this video so you have context. So let's zoom in and look closely at the function of RDRP, because that's going to tell you why remdesivir may or may not work. So here's our RNA-dependent RNA polymerase, and here's our viral RNA, and you can see the nucleotides here, A, U, G, C, G, C, U. What RNA-dependent RNA polymerase is, whenever they see an A on the first strand, it will create a strand that has a U. Whenever they see a U, it will put in an A. Whenever they see a G, it will put in a C. Wherever it sees a C, it will put in a G, and so forth and so forth. And the way that this works is it always creates RNA from the 5' end to the 3' end, which means that it's reading the template RNA from the 3' end to the 5' end. So here it's coming up to the next nucleotide, and there's these things floating around, and they have 3 phosphates on them. All of them have 3 phosphates. And so the way that this is abbreviated as they're floating around in the cytosol, for instance, if this is an A, this would be known as A, adenosine triphosphate, or ATP. This one here would be known as UTP. And what happens is, as these nucleotides, which are just floating around in solution, there's a spot that opens up, and because this is a G, one of them that has a C on it and 3 phosphates will nicely bind in here, and it will form a C, and it will continue to go on. I'm just going to erase some of this here so that we can see it a little bit more clearly. The thing that's really interesting about this is when it comes to the time when there is a U that opens up, ATP should normally go in there. Remdesivir, as we'll abbreviate RDV with a 3 phosphate on the end of it, actually binds into this U state better than the A, and so it will go in there instead. And here's the nice thing about RDV in this situation. As soon as RDV binds, as this RNA molecule is being copied, about 3 or 4 nucleotides down the line, it causes the RNA-dependent RNA polymerase to stop. It arrests RNA-dependent RNA polymerase. And if you scroll down to the bottom, you can see that remdesivir triphosphate is very similar to adenosine triphosphate. Look at the structure. It's going to fit very well inside of that spot as the RNA-dependent RNA polymerase is going by. But if you have a concentration of RDVTP in the cytosol, it will suck one of those in and arrest elongation. If you arrest elongation of the RNA, you can't make viruses, and you stop the infection in its tracks. So you can see why this medication has a lot of promise. But again, we have to do the randomized placebo-controlled trials, and those are underway as we speak.